A demo on your laptop is not a client deliverable. Let me be specific about what that means. Episode 2 and 3 build a production quality agent, persistent Redis memory, 3 tools, a rack knowledge base, a human approval gate on every outbound email. That is the logic layer. But it runs on Docker desktop on your machine behind localhost. No SSL, no authentication, restart your container, and any queued execution vanish. That is not what a client gets. This episode, in the infrastructure layer, we move the same agent to a VPS. Add SSL via Caddy, enable queue mode so execution survive restarts, add a second specialist agent using the multi-agent skill router pattern. Eval through the 5-point governance checklist I hand to clients on every n8n delivery. By end of this, you will know what differentiates a demo from a billable system. Let us start with the gap. Here is the exact difference between what we built in episode 2 and 3 and what a client actually receives. I want to put the specific differences on screen because developers often underestimate how large the gap is. On the left, the demo. Runs on Docker desktop your laptop, single worker n8n, no queue mode, no SSL. The client would have to access it at your IP address on port 5670. No authentication, anyone with the URL can access the canvas and all credentials. Credential strings in your environmental file on your machine. Restart the container and any in-progress executions that were paused at wait node are gone. No other trail beyond what you see in the browser. On the right, what the client gets. Run on a dedicated VPS, queue mode enabled, Redis backs the execution queue, so work survives, restarts, and can scale horizontally. SSL via Caddy, yourdomain.com, automatic Let's Encrypt certificate, zero configuration HTTPS, authentication like n8n user accounts with scoped RBIC, credentials encrypted in the n8n vault, never in files, execution state in Postgres, a paused wait node resumes exactly where it left off after a server restart, full audit log, execution, every LLM call, token counts, latency, everything. Each item on the right is a reason a client signs an invoice. Each item on the left is a reason they do not. So if you go back to Visual Studio Code again, you can see in the episode production 4 folder, there is a Docker folder and Docker Compose YAML is there as an example. You can get it, you can copy it, you can run it. Here is the full production stack we are going to build. 4 services in Docker Compose file. At the top, Caddy. This is the reverse proxy and SSL terminator. You point your domain at the VPS, write 3 lines in a Caddy file, and Caddy handles Let's Encrypt certificate acquisitions and renewal automatically. HTTPS with 0 manual SSL config. Below Caddy, n8n in queue mode. The critical environment variable is executions mode equals queue. This changes n8n from a single process setup to a main process plus worker process architecture. The main process handles the API, the UI, and the workflow triggers. Workers pick jobs from a Redis queue and execute them. The separation means the UI stays responsive while a long-running agent is executing. At the bottom, Postgres and Redis side by side. Postgres stores everything persistent, workflow definitions, encrypted credentials, all execution history, the audit log. Redis has a dual role in this stack. It backs the n8n execution queue and it is the same Redis that stores chat memory from episode 2. One Redis instance, 2 purposes. Total VPS cost is €6 a month on Hetzner CX22. 2 virtual CPUs, 4 GB of RAM. Compare that to Zapier Teams at over $100 a month before you hit the task limit. So again, go back to Visual Studio Code and here you can see the Caddy file, Caddy2 Alpine, n8n worker is here, Postgres is here, and Redis is here. So let us walk through the Docker Compose YAML file line by line. That was it. So the full Docker Compose YAML is in the GitHub repo under the episode 4, as you see. I'm going to walk through the important parts. The Caddy service is the simplest. The official Alpine image, ports 80 and 443. A volume mounting the Caddy file from repo. The Caddy file itself is 3 lines. Your domain name, reverse proxy pointing to n8n port 5678. Caddy reads it, acquires the certificate, and starts forwarding HTTPS traffic to n8n. The n8n service has 4 environmental variables that matter. Executions mode equals queue enables the Redis backed queue. DB type equals Postgres DB, and Postgres connection variables tells n8n to store everything in Postgres instead of SQLite. So queue bool Redis host equals Redis. tells the queue layer where Redis is. The service name in the compose file is the host name within the Docker network. n8n encryption key is the key that encrypts all credentials stored in n8n database. Set this to a long random string. If you lose it, your stored credentials are unrecoverable. So the n8n worker service is important. This is what actually executes workflows in kube mode. Same image as n8n. But the command is worker. Same environmental variables. It connects to the same Redis queue and picks up jobs as they arrive. You can run multiple workers by scaling this service. The Postgres service is standard. Postgres 16 Alpine. Environment variables for the database name, user, and password. These come from an environment file that is never committed to Git. It's listed in the Git ignore. The Redis service uses the same configuration as episode 2 and 3. Redis 7 Alpine, append only yes for the disk resistance. Run a Docker compose up -d on your VPS. Wait 2 minutes for Caddy to acquire the certificate. Navigate to your domain. Your n8n instance is live at HTTPS with no self-signed certificate warnings. Now let us add the second agent, the product specialist agent. Episode 2 gave the agent 3 tools. Episode 3 added F4, the rack search products tool. But there is a design problem with a single agent that has 4 tools and the ability to call web search, CRM, email, and vector search. As you add more tools, the agent context grows. More tools in the prompt means the agent takes longer to reason about which tool to call and is more likely to make routing errors. The industry solution is specialization. Break the capability space into specialists and use a generalist agent as a router. Here is the pattern. The generalist agent handles everything it can directly: web search, CRM lookup, and email drafting. When it resolves a query that is clearly product related, it delegates to the product specialist agent by calling a tool named product specialist. The product specialist tools a workflow tool node that calls a sub-workflow. That sub-workflow is its own React AI agent, the product specialist agent, with its own system prompt, its own tool access limited to search products, and its own specialized persona. A product expert who answers with specs, comparisons, and citations. The generalist agent gets a response back from the specialist, incorporates it, replies to the user. From the user's perspective, there is one agent. Under the hood, there are 2. The critical implementation detail, and I want to emphasize this because it's where most people get stuck. The skill name in the workflow tool node must match the sub-workflow name exactly. If the tool is named product specialist, the sub-workflow must also be named product specialist. n8n uses the same name to find the sub-workflow at execution time. Mismatch and the tool calls fail silently. This pattern scales to any number of specialists. You want an email drafting specialist with a compliance-aware persona. Create the sub-workflow, add the workflow tool node, give it a precise description, and the generalist agent routes to it automatically. The cost of adding a specialist is 1 sub-workflow and 1 workflow tool node configuration. Nothing more. Let's go back to Visual Studio Code. Under the workflows, you can find the generalist agent as a Slack trigger, generalist agent itself, and a tool product specialist. You can call tools and specialist here and the reply. And we can check now the product specialist agent JSON. Here it is. So it is the same, but it's a specialist. It's a product specialist agent. So it can use the search products tool. That's it. Now I want to revisit the human in the loop pattern from episode 2 because in production, it needs one additional consideration. We covered the HITL pattern in the episode 2. Draft an email, hit the wait node, send a Slack approval message, resume on button click, send or delete. The core pattern is unchanged, but there is a production consideration we skipped in the episode 2. What happens if the approval Slack message is missed? In a demo context, this does not matter. The execution hangs and you notice eventually. In a client context, it's a problem. An email stink in draft for 3 days awaiting for approval while the client thinks it was already sent is a client relationship problem. The production answer is a scheduled reminder. After the wait node fires and the approval message is sent at a parallel branch, a scheduled workflow that runs every 24 hours, queries Postgres for executions in the waiting state, and sends a reminder Slack message with the original draft preview and the approval buttons. The resume URL is stored with the execution state in Postgres, so the reminder can reconstruct the full approval message. This is one of those production details that does not appear in any n8n tutorial, but every client eventually asks about. You build it once, document it in your governance checklist, and it is included in every delivery. The second production consideration is logging restrictions. When the agent draft is rejected, the rejection reason should be stored, either in Postgres via a write to file node or in Airtable. So you can review what the agent gets wrong and improve the system prompt over time. Rejected drafts are your highest quality training signals. So let's go back to Visual Studio Code again. Let's see the HITL email approval JSON. We have a start, create draft, notify approvals channel, wait for decision, approved, send, and mark rejected here. Now the 5-point governance checklist. Governance point 1. Credentials never touch the workflow JSON. Here is the failure mode I see frequently. A developer builds a working n8n workflow, exports the JSON to GitHub, and exported file contains raw API keys in the parameters. Oh god. OpenAI key, Slack token, Airtable API key. All visible to anyone with repo access. Git history preserves them forever even after deletion. The n8n credentials vault prevent this. Every API key goes into the vault. Settings, credentials, new. The workflow node references by credential by ID. A string like cred7 multiplied with 2k, not the actual value. When you export the workflow to JSON, the exported file contains the only credential ID. The actual key never leaves the encrypted Postgres storage. That's it. The practical consequence, you can commit workflow JSON to a public GitHub repo safely. The JSON contains no secrets. Anyone who imports it needs to create their own credentials in their own n8n instance. The audit requirement I include in every client delivery confirm that no raw API keys exist anywhere in the n8n file system. The environmental files pass to the n8n container or workflow JSON. All secrets in the vault, always. Look, in the Docker folder, we have an environmental file example. We have the domain, n8n encryption key in it, Postgres information, and the Redis password. Everything in this file. Governance point 2, access control, role-based access control. n8n has 3 built-in roles: owner, admin, and member. The agent's production user account should be a member, never admin, never owner. More important than the role is the workflow access scope. In n8n, you can restrict a member to specific workflows with execute-only permissions. The agent user can trigger and execute the main agent workflow, the search web sub-workflow, the draft email sub-workflow, and nothing else. It cannot create workflows, it cannot view or manage credentials, it cannot modify existing workflows, it cannot see the other users' executions. Why does this matter? If the agent account is compromised, if an attacker gets access to the n8n API with that credential, the blast radius is limited to what that account can do. It cannot exfiltrate all credentials, it cannot modify other workflows. Least privilege principle applied to the agent layer. Governance point 3, the audit log. n8n Postgres backend stores every execution, the workflow ID, the status, the start time, the duration, and every node's input and output data. For LLM call nodes, this includes the model, the token counts in and out, and the latency. This is not a just debugging tool. For regulated industries, finance, healthcare, legal, the audit log is the paper trail that demonstrates the AI system operated within defined boundaries. Who initiated what action, when, which model was used, what it received, and what it returned. Query it with a direct Postgres connection or pipe it to your client's BI tool. Choice is yours. Governance point 4, error handling and idempotency. Every HTTP request node in a production workflow needs 2 things: a retry policy on 500 responses, retry up to 3 times with exponential back, and idempotency key, a composite identifier that prevents the same action from being taken twice if a retry fires after the original action already succeeded. The pattern for the idempotency key is simple: concatenate the execution ID and the record ID. Store this key in the Postgres before the action. On retry, check if the key exists. If it does, the action already completed. Return the cached result. If it does not, execute the action and store the key. This matters for the email tool. Without idempotency, a transient network doing Gmail send could cause the draft to be sent twice. With the key, the second attempt detects first completed and does nothing. Governance point 5, execution limits. Without limits, One misbehaving agent can exhaust your API quota and VPS memory. 4 limits I set on every production n8n deployment. Execution timeout 5 minutes. If a single workflow execution runs longer than 5 minutes, it is cancelled. This catches infinite loops and Hanka API calls. React loop iteration cap 50. The agent cannot reason for more than 50 steps before being forced to call final answer. In practice, you never hit this. Normal queries are 3 to 5 steps, but it is a cost ceiling. Redis memory window 100 messages per session. Note that the oldest messages are prune. This prevents memory sessions from growing unboundedly and consuming Redis RAM. Concurrent workers 2 matches these 2 virtual CPUs on the Hetzner CX 2020 and 22. Running more workers than core means context switching overhead with no throughput gain. Let me put a number on what this infrastructure saves versus cloud automation platforms. The economics of self-hosting become clear at about 200 executions per month. Below that, the time cost of hosting may outweigh the savings. Above that, every additional execution is free. Here is a concrete comparison. A 20-step AI agent workflow that is roughly equivalent to what we built across episodes 2 through 4, running 1000 times per month. On Zapier teams, 20 steps times 1000 runs in is 20,000 per task per month. Zapier charges per task. That is the range of $400 to $600 a month. At 5,000 runs, it scales proportionally, closer to $2,000 per month. On n8n self-hosted, the cost is the VPS, 6 to 12 euros per month, depending on the instance size. 1,000 runs and 5,000 runs cost the same. The VPS is a fixed resource. The break-even point in practice is 2 to 300 execution per month. Below that, use n8n Cloud or make if you prefer managed services. Above that, self-hosting is clearly cheaper. You get full control and you are not subject to platform pricing changes. The argument for self-hosting is not just cost. It is data sovereignty. Your data stays on your infrastructure. It is customization. You can install community nodes, modify the source, run behind corporate firewall, and it is predictably the bill is the same whether the agent is the idle or running at capacity. Let me put all 5 governance points on one slide as the client delivery artifact. This is the governance checklist I include every n8n system I deliver to a client. It's a physical document, usually a PDF, signed off before go live. Point 1. Credential isolation confirmed. All API keys in the n8n vault, no raw secrets in the workflow JSON, no environmental files mounted to the n8n container, no hard-coded values in code nodes. Point 2. RBAC scope. Agent production user created with member role. Workflow access restricted to executions only on the required workflows. No admin access error. Verified at delivery. Point 3. Audit log confirmed. Postgres execution history enabled. LLM call tracking on. Client has read access to the audit log database and the query to retrieve it document. Point 4. Error handling and idempotency implement. Every external API call has the retrieve policy. Every write action has idempotency key. Error workflow routes failures to a designated Slack alert channel. Point 5. Execution limits set. Timeout loop, iteration cap, memory window, and concurrent worker count all configured and documented. No runaway cost scenario possible. This checklist is not overhead. It is what separates a professional delivery from a demo you hand off and hope works. Clients in regulated industries like finance, healthcare, legal increasingly ask for exactly this checklist before they will sign a go live sign up. So I didn't forget to put this in the GitHub too. So if you go to governance folder, there's a production governance checklist here. 1 to 5 steps. All are here that I have mentioned. Let me close out the series. 4 episodes, 1 production system. Episode 1 was architecture and positioning, why n8n for a client work, the honest Python comparison, the node taxonomy, why the workflow tool node changed everything. Episode 2 was the persistent memory Slack agent, Redis session ID pattern, 3 workflow tool nodes, and the HITL wait node pattern. Episode 3 was the RAG layer, the same quadrant collection from the hybrid search series connected to the agent, source citations, the honest trade-off between naive dense search and the full hybrid pipeline. Episode 4 was production. Self-hosted stack, multi-agent skill routing, hardened HITL, 5-point governance checklist. Every workflow in this series is importable from GitHub. The repo is linked below. If you want to work with me directly on building or deploying systems like this, my Upwork profile is linked in the description below again. This is what Beyond the Developer means. Not just the code, the infrastructure, the governance, the client-ready delivery. If you like this video and if you want to keep coming like this, please subscribe and like this video. See you in the next series.